Let's go ahead and take a look at a quick overview on factoring polynomials. So these are really the general steps that we're going to be following when looking to factor any polynomial. First and foremost, the most important thing that we always want to check first is there a greatest common factor that we can take out all of the terms of our polynomials. Step number one every time. After we do that, we're going to check to see if the remaining polynomial is in fact quadratic. If it's linear, it's already factored as far as it can go, and if it's cubic or quartic or so on, it's beyond the scope of this class. We're not going to worry about it until probably next year, so don't worry about that. If it is quadratic, we want to see if we can factor it using one of our quick little shortcut methods there, either as a difference of squares, meaning that it came from a sum and difference pattern, or if we can factor it as a perfect square trinomial, meaning it came from the square of a binomial. If we can't use either of those methods there, we're going to have to go ahead and try and use this using our just run-of-the-mill AC method. And after we're done with all that, if we followed the steps accordingly, we're going to be done. Let's take a look at a few examples. Alright, example number one here. We're starting out with a quadratic. Looking at each of the three terms here, we can see that we can take out our greatest common factor of 2. Every term is divisible by 2. So if we factor a 2 out from each term, we're going to put our common factor out front. And what we'd have left over from our original polynomial would be x squared plus 6x plus 5. Taking a look at what we have remaining here, we can see it's a quadratic, it's a trinomial. It doesn't look like any of our little shortcut methods are going to work here. We don't have perfect squares for our first and last term, so neither of those are going to work. Let's try and factor this using the AC method here. So a times c, 1 times 5 will give us 5. And our b here, our middle term, is 6. So we are looking for two numbers that multiply together to give us 5 and add up to 6. Those two numbers in this problem would be 5 and 1. Those are the two numbers that will work for both of these. Since our a happened to be 1 here, we can use a little shortcut here. We can see that this trinomial is going to factor to be x plus 5, since one of our numbers was a positive 5, times x plus 1, because our other number was a positive 1. Don't forget about our common factor of 2 that we pulled out at the beginning, and our fully factored polynomial here is 2 times x plus 5 times x plus 1. Moving on to example 2. We'll start this one the same way. Again, we see this is a quadratic trinomial. We should know how to at least try and factor this. Looking for a greatest common factor, we can see that there isn't one here. There's no number that goes evenly into all three terms. So we're just going to skip step number 1. Doesn't apply. Let's see if we can use one of our shortcut methods here. We can see that our first term is a perfect square. 9x squared is a perfect square. Looking at our last term, it's a perfect square as well, 4. Taking the square root of each one of those, we can see that our a, since our first term here is really our a squared in the pattern, our a would work out to be 3x. Looking at our last term, our b, since our last term is really b squared, our b would work out to be 2. Just to check real quick, we should remember that our middle term in this pattern should always work out to be 2 times a times b. Checking this here, we can see that 2 times 2 is 4, times 3x is 12x, and this says we should have a minus 12x. So all that really is going to mean here is that, well, since this is b squared, b really could have also been negative 2. Negative 2 squared would still give us our 4, only it causes this kind of middle term here to check out correctly this time, which is good. Since everything looks like it should fit our pattern, we know our final answer would be 3x minus 2 quantity squared. The 3x from our a, and the minus 2 from the b, and then the quantity squared to make this a binomial squared. Real quick on example 3, we see we can take out a common factor of 3, leaving us with 3y squared minus 2y plus 7. Looking at the remaining trinomial, you could try and do a sum and difference. You can try and product sum, but this is not going to be factorable any further. This here is our final answer.